I'm really honored to introduce our next speaker. She's Dr. Chantal Farmer. Chantal is a research scientist with sow lactation biology, working at Sherbrooke Research and Development Centre of Agriculture and Agri-Food Canada. She obtained her BSc from McGill University, her MSc from the University of Saskatchewan, and her PhD from Pennsylvania State University. She is a pioneer in studying mammary development in gilts and sows and identifying the reasons affecting this. She has very well published over 160 scientific manuscripts, 9 book chapters, and is the editor of 2 books that have been translated into Chinese. We're very honored to have her. Her expertise is recognized across the world. She's spoken in 13 different European countries, as well as China, Australia, Canada, and in the US. Also, she's recently received the President's Award for International Achievements in Animal Science. So with that, please help me welcome Dr. Farmer.
Thank you, Jenny, for this introduction. And the first thing I want to say is thank you to the organizing committee for having invited me. I know I'm very young, but I've heard for a long time about the Leman conference, and this is my first opportunity to come. So thank you, Jenny, thank you, Mike, for inviting me. It's a pleasure to be here today and to have this chance to talk about increasing sow milk yield through greater mammary development in prepubertal and gestating gilts. What do I want to talk about today? First, I want to give you some knowledge about mammary development. Why is it important? Why even bother about mammary development? When does it take place? And what affects it? So hormones, 3 major hormones I will discuss. And then we move on to nutrition and mammary development, both in prepuberty and in late gestation. Then I will move on and talk about body condition. Does body condition of a gilt affect its mammary development? Again, in late gestation and at puberty. And lastly, just for fun, because it's such an interesting study, I want to talk about the effect of management in first lactation on mammary development in the second lactation, so the effect of teat use in first lactation and whether it impacts mammary development of that teat in the next lactation. And then I will have a short conclusion. I think I'm going to stand on this side. Might be easier that way. Okay, the sow is not producing enough milk to sustain maximal piglet growth. You take a baby pig, and on top of the milk it's receiving from its dam, you give milk through an artificial bottle. The pig will drink that milk and will grow more. The pig can grow more than what the sow is giving in terms of milk. So the sow is limiting growth rate of her piglets. Let me move this up here. Sow is limiting growth rate of her piglets, so anything we can do to improve sow milk yield will be beneficial. Are you hearing me right? Is that, yeah? I thought it was not loud enough. And then we discussed, in the first talk, it was shown clearly, yes, we've increased litter size. Wonderful, genetic companies should be applauded. They've done a great job. Now I have to work. Because with all these piglets born, they need to drink milk. Yes, but it's created a new problem. Because each of these little piglets is actually getting less milk than a while back. So I keep wanting to retire. I don't know if my husband is happy, but I don't retire. I work and work. I think he's happy, actually. It keeps me out of his hair. Okay, so what can I do to increase milk yield from a sow? One of the main factors that will affect the potential of milking is the amount of, or the number of cells that synthesize milk. The greater number of these secretory cells that you have at the beginning of lactation, the greater milking potential for that sow. It's also been shown that there's a correlation between the size of a mammary gland and its milk yield, which is measured by the weight of the piglet nursing that gland. And this is a conclusion from an early paper that I just love. Replacement gilts should be managed in order to enhance the mammary development. And I said, this is just as bad as reading a murder mystery, getting to the end and not knowing who the murderer is. Oh, fine. How do I do this? Well, this is what I'm going to talk to you about. We will cover some of what you can do to achieve that. Okay, a mammary gland. Basic things I'm sure that everybody knows, but we'll go over it again. You have a cross-section here of a mammary gland. In the teat, you have two lactiferous ducts. You milk a sow, you see two streaks of milk, everything is normal. These ducts will ramify into ductules, at the end of which you will have alveoli. The cells around the alveoli are the epithelial cells that synthesize the milk. Two words in red here are the words that are really important to remember. Parenchymal tissue is a good tissue that does contain these epithelial cells. You want to increase the amount of parenchyma in the mammary tissue. Extraparenchyma is in fact the layer of fat around the mammary tissue. So this is not really related to the amount of milk produced. So when does mammary development take place? At birth, you have mainly stromal tissue, very poorly developed duct system. Then in the life of a pig, you have 3 periods of mammary development. You have one which is actually even before puberty, starting at 90 days of age up to puberty, stage 1. Then in the last third of gestation, from 90 days of gestation, so it's easy to remember, 90 is the key number, 90 days of gestation to farrowing. Then you have lactation. As a scientist, I'm mostly interested in those two first periods because I want the animal to start lactation already with the optimal amount of cells that can synthesize milk. One thing that is very, very important, during only these periods where you do have mammary development, you can do anything to try to stimulate it. I say 3 times 0 will give you 0. If there is no mammary development, I don't care what hormone or what feeding you will do to that gilt. It will not have more of a mammary development because she's not at a stage where she is developing her mammary tissue. So it's only in these periods where you do have mammary development, and I will show proof of that later on. It's only in these periods that you can do anything to try to enhance it. Martin Sorensen in Denmark was a pioneer looking at mammary development, and you can just see here in numbers what I've told you. Age of the animal in days, and DNA, which gives you an idea of the number of cells in the mammary tissue on the vertical axis. So around 90 days of age is when you start to see mammary development up to puberty. Then puberty happens. What occurs? Hormones, mainly estrogens, are coming into play. And what do you see? An increase in parenchymal tissue, important duct system related to the production of estrogens. Then you breed the animals, as I mentioned before, 90 days of age is the key word. So 90 days of age is about when you start to see increase in mammary development. What controls mammary development? Hormones are important, and they're important also because they will affect the nutritional treatment that you will try to use to stimulate it. So you have to bear with me when we talk about hormones. They're important. And 3 of them, most importantly, estrogens, prolactin. IGF-1 is in fact a growth factor, insulin-like growth factor 1, which is the mediator of action of somatotropin, or growth hormone. So let's start with estrogens. As I mentioned before, estrogens are important at puberty, but they're also important in late gestation. Estrogens are produced by the fetal-placental unit, so they come from the fetal origin. And you can see that on day 110 of gestation, there's a positive correlation between the concentration of estrogens in the blood of the dam and the DNA in the mammary tissue. So there is a relation. And these authors have concluded that estrogens do have a positive effect to stimulate mammary development in late gestation, and it could be through an increase in prolactin receptors. Now, why prolactin receptors? Why would that be important? Let's talk about prolactin. In 1945, it was shown that if you feed barley ergots for the last either 25 to up to 87 days of pregnancy, you see almost no water development, and you see an absence of milk, agalactia. In those days, they did not know why that happened. Then in the 1970s, the radioimmunoassay for porcine prolactin was developed. And then it was shown when you give barley ergot, you decrease prolactin in the sow circulation. So that's why you saw that effect. So if you give too much of the toxin that you have in barley ergot, it will decrease prolactin and will have a negative effect on mammary development and milk yield. Now, to look more specifically at the action of prolactin, I've used inhibition studies, because there's more than one. First, let's see how is prolactin regulated. Prolactin is under negative control through dopamine. More dopamine you have, less prolactin. If you can inhibit dopamine, you will increase prolactin. So in this study, I've used a dopamine agonist, bromocriptine, to inhibit prolactin. So in this right-hand side, I have a control animal that had no inhibition of prolactin throughout gestation. You see the nice pink parenchymal tissue and the fat layer around, the extra parenchymal tissue. Now from day 70 to 110 of gestation, when I inhibited prolactin using a dopamine agonist, you see on the left-hand side, things are really not going well. A lot of fat around, much more extra parenchymal tissue, and more fat in the parenchymal tissue. So very, very, very inhibited mammary development. Then I wanted to see, is there a specific time period, between 70 and 110, where prolactin is most important? And it goes back to what I was saying earlier, 3 times 0 gives 0. Between 50 to 69 days of gestation, doesn't matter if you inhibit prolactin. Same thing between 70 and 89. Aha! When you come to the period where you do have rapid mammary development, between 90 and 110 days, there you have a significant effect. If you inhibit prolactin in that period, decrease the weight of the half-dand, significant decrease in terms of parenchymal tissue, and you also affect the composition of that parenchymal tissue by having more fat, less protein. So, significant impact. If prolactin is important, why not just give it? Could that be beneficial? McLaughlin and collaborators in 1997 did a study where they injected prolactin to growing gilts to increase their growth rate. And interestingly, there was one sentence that I clicked on, and I'm really happy that they wrote it there. They said that visually they could see mammary development on these animals. So then I've done the exact same treatment in a study. So I injected porcine prolactin, recombinant porcine prolactin for 29 days, same as McLaughlin did, starting at 75 kilograms. But then I slaughtered the animals and I collected the mammary tissue and I looked at it. My goodness, look at this. Whether you give 4 or 8 milligrams of porcine prolactin doesn't matter, so there's no point in giving too much. And if you give 4 milligrams, you have a doubling in parenchymal tissue. Great positive effect. And you also affect the composition of this tissue, more protein, and look at the DNA, the concentration of DNA. So greater number of cells for a certain amount of tissue. If you look at this underline of the gilt, you can see already, that's what McLaughlin said, visually you can see that there is a development. Normally this line is flat. But what we also saw when we slaughtered the animals, we saw some lacteal secretions. Boy, that animal is not even bred yet, and she's got some lacteal secretions. So this is something we have to keep in mind. Is that negative? I mean, I slaughtered the animals. I have no clue what would have happened in terms of milk yield. Yes, we stimulated mammary development, but if we got the animal to produce milk too early, would that be harmful, or if it would be okay? I don't know. I don't have the answer for you. Basically because there's not enough, now there's no more porcine prolactin recombinantly produced that's available. So we had to turn to other solutions to stimulate prolactin. And in this case, what we've done is we've used pharmacological agents that are dopamine antagonists, removing the inhibitory factor to increase prolactin. So that was done in that critical period, days 90 to 110 of gestation. We increased prolactin using domperidone, and we saw an increase in alveolar volume of the mammary glands, greater milk yield in the following lactation, greater weight of the piglets, 21% increase during the following lactation, and no change in milk composition. So wonderful, wonderful. If I can increase prolactin in late gestation, we'll be fine. But to do commercially, that's difficult, unless veterinarians go to every farrowing unit at the end of gestation to give that product. Producers can do it themselves. So I tried to find a solution, and one idea was to use a milk thistle extract that's called silymarin. That milk thistle extract was shown to increase prolactin in rats, to increase milk yield in humans, and in cows. So that could be wonderful. Put it in the feed in late gestation, and we will solve the problem, increase mammary development. So I fed this to sows, 4 kilograms per day, in late gestation or throughout lactation, and yes, I did increase prolactin, but never to amounts that would be needed to increase the milk yield and the mammary development. So some increase, but not large enough. Somebody may ask me, okay, why didn't you give more? Because commercially, economically, it wouldn't be feasible for a producer to give more. So if you give more than 4 grams per day, the advantage you would gain wouldn't be enough to pay for it. Obviously, if somebody would produce silymarin in very large amounts and it would be cheaper, then an option would be to go back and do a study and give more and see if that would be enough to increase prolactin to stimulate mammary development. Now we'll move to IGF-1, insulin-like growth factor 1. I've done a study with somebody in the Netherlands, who you might know. We've increased concentrations of that growth factor by giving injections of somatotropin, again in that critical period, days 90 to 110 of gestation. What happened? Again, look at this, significant increase in parenchymal tissue weight, and also changes in terms of its composition with more DNA, so more cells, and more RNA, which gives you an idea of the metabolic activity. You have more tissue with more cells that are more active. So this is really positive effects. Right now, it's important to know, how can we, through nutrition, increase IGF-1 concentrations? And I know a company is working on this, trying to develop nutritional strategies to increase IGF-1 concentration in the animal, so we could do this in late gestation and improve mammary development. So let's talk about nutrition. What do we know on the effect of nutrition on mammary development? When you talk about prepubertal gilts, obviously there's a question. Are replacement gilts currently fed to maximize their mammary development and future milk yield? Well, first of all, do we know how we need to feed them to maximize that? There were some adjustments made in feeding of the gilts, increasing the ratio of amino acid to energy, increasing calcium, phosphorus. Yes, some adjustments were made, but those were not made keeping in mind mammary development per se. And when you consider that the goal of these two animals is completely different, then it's important to really know how best to feed the gilt to maximize her mammary development. What do we know? If you do a 20% feed restriction in that period that is critical between 90 days of age to puberty, you will significantly decrease the amount of extra parenchyma, which doesn't really matter, but significantly decrease the amount of parenchymal tissue. So not good. You don't want to do that. Another study was done by Martin Sorensen, where he did the 26% feed restriction in 2 periods, either between 28 to 90 days or 90 to 170 days. Interestingly, we see again the theory that 3 times 0 gives 0. If I inhibit feed intake in a period where there is no mammary development, well, there is no negative effect. So if you want to restrict feed intake, you can do it before day 90 of age. But then, if you restrict feed intake as of day 90 of age, then you're in trouble, because ad lib fed animals will have more mammary tissue, more DNA, and more RNA. You will tell me, yes, but why do you even talk about feed restricting gilts? Nobody will do this. That was in 2006. Maybe nobody was doing it in 2006. Now we're in 2022, and people come to me and say, we have a problem. We have gilts that are growing really fast, that have a lot of leg problems. We want to slow their growth rate. Can we restrict feed intake? Oops. That's what I know. So we've done another study more recently with the University of Guelph, with Leanne Huber. And we wanted to see, can we do a restriction that is less than 20% to slow down the growth rate of these gilts and make sure that their milk yield will be fine. So we've done either, you see control animals, 10% feed restriction compared to these controls, 20% feed restriction, or feeding a high fiber diet, 25% more fiber that will dilute the energy by 5%. And these animals were fed ad libitum. And in that case, sadly enough, COVID came. We had two studies. I was doing these exact treatment, slaughtering the animals and looking at mammary tissue. 1 month before I was to slaughter the animals, the government said, we're cutting everything. Because of COVID, it's dangerous. I'm like, excuse me, there's $100,000 there. This is being recorded. I shouldn't say this, but anyway. So they cut down my project anyway. So all we had done was wasted, and I don't have the answer for you what it does to the mammary tissue. The answer I have is what it does, well, in terms of milk yield. I will share the milk yield data with you in a second, but before that, I wanted to show you what it does in terms of growth rate and back fat thickness. So obviously, if you do a 20% feed restriction, you have a greater impact in terms of body weight of these animals. So the greatest reduction in growth rate was in this 20% reduction. 10% reduction in growth rate was similar, in feed intake, had a similar effect on growth rate than this increased fiber. And the same thing is seen in terms of back fat thickness. Well, so it just makes a lot of sense, but at least it gives you some numbers of what the weights of these animals were. Then you go into the next lactation, and you look at growth rate of the pigs, and there was no difference. Wow, so now this is telling me it doesn't matter if I've done this feed restriction. But, one point is very important. When you look at the previous studies, the control animals were eating in the older studies, they were eating 2.88 kilograms per day. They had a lesser capacity to eat. And in this current study, they're eating 3.5. So our gilts now are eating more. So when you do a 20% feed restriction, the amount of feed that you give is totally different. Nowadays, a 20% feed restriction was 2.7 kilos. Earlier study, it was 2.1. So there may be a minimum amount of feed that the growing gilt has to receive to make sure that her mammary development will be okay. In this case, 2.7 kilo per day seemed to be fine, but 2.1 is not. I don't know if it's somewhere in between, but I can tell you, if you don't go below 2.7, then you should be okay. How about restricting the amount of protein that the gilt is fed? If you do a 14.4 compared to an 18.7% crude protein from days 90 to puberty, no effect on mammary development. So restricting protein by itself doesn't have an effect. How about if we try to feed something that has an estrogenic effect, because we know that estrogens are important? So I've done a study using flax. We have a lot of flax in Canada anyway. So I've used 10% flaxseed because the flaxseed contains oils, but it also contains lignans, which have estrogenic properties. So I fed this 10% flaxseed to prepubertal animals in that critical period, increased, as you expect, the N3 polyunsaturated fatty acids in the blood of these gilts, but no effect on mammary development. Okay, fine. Flax isn't working. The estrogenic effect is not great enough. How about if I use a plant source of estrogen that may be more estrogenic? So in this case, what I've used is genistein, which is a plant estrogen. So I had my standard soy diet, or that diet, plus 2.3 grams per day of genistein from days 90 to puberty. Increased phytoestrogens in blood, also increased by 44% the number of cells in parenchymal tissue, the concentration of cells. So yes, if I can do something to increase estrogens in these growing gilts, it will stimulate mammary development. That's how we know about the growing gilt. Then we go to the gestation part in gilts. How about nutrition? If you increase energy intake to overly large amounts, 10.5 megacal of ME per day, which is quite high, compared to 5.7, it will either decrease mammary development, it will either have no effect. In the case here, increased parenchymal fat, which really doesn't make much of an effect in terms of milk yield. And in the last case, polyunsaturated fatty acids were increased with no effect. So basically, what I'm telling you here is increasing energy intake to a large amount in the end of gestation is not beneficial. That's not the way to go. Okay, let's look at protein. An old study measured, looked either 330 or 216 grams of crude protein per day, starting on day 76 of gestation. No effect. But when they looked at 4, 8, or 16 grams per day of lysine being fed, even though the mammary development was not affected, in the next lactation, milk yield was greater in the sows that were fed 16 grams per day. So this led to a study that's more recent by Che and collaborators in 2019, where they said, let's increase the lysine amount in the diet and see if that has an effect. So in this experiment, they increased by 40% lysine. So the estimated requirement of these gilts was 14.7. They increased it to 20.6, with obviously all other amino acid requirements being met. And then they looked at the average daily gain of the piglets in the next lactation. Significant increase. They also had a tendency for birth weight to be increased. So they said the greater gain of the piglets in lactation is either due to the tendency for increased birth weight or to greater mammary development. Perfect. Now I come and I do a similar study, but I slaughter the pigs and I look at the mammary tissue. So in this case, 40% increase in lysine, my estimated requirements was greater than the one in Che, so that was 18.6. We increased to 26 grams per day. Everything isoenergenic, everything else is fine. Again, from days 90 of gestation onward, on day 110, we slaughtered the animals. Important to say that in that study, we've increased the lysine by adding soybean meal. We know soybean meal may contain other components. We know soybean meal will also increase protein. The goal was to increase lysine by 40%, which we did, but that's important to mention. So on day 110, we looked at mammary tissue and fetuses. The body weight gain of the gilts was greater. The fetal body weight, when you correct it for litter size, was also greater. And what's most interesting is this, the mammary tissue. Parenchymal weight, significant increase. 44% increase in parenchymal weight, 40% increase in lysine. Boy, that's a one-to-one relation. If you look at parenchyma petite, obviously it's similar again. And the composition of the parenchymal tissue is not altered. When you look at percentage and concentrations, you have more total DNA and more total RNA. Why? Because you have more parenchymal tissue. So really the effect of increasing lysine is on the amount of parenchymal tissue. Okay, and before I go on, I want to say, right now, we will be planning a study, again with Leah Neuber and Guelph, where we will try to pinpoint, is that effect due to soybean that may contain other things that could be advantageous? So we will have a soybean study, we will have a casein study with the whole protein, or we will have a treatment where we add specifically lysine. And again, we'll look at mammary tissue and we will be able to pinpoint which, is it really the lysine that has an effect? So this is coming. Then I tried the flax again in gestation, 10% flaxseed. Interestingly, it had no effect on mammary development or milk yield of the animals that received the flaxseed in gestation and lactation. But when I looked at the baby pigs from those females, when these animals reach puberty, they had 31% more parenchymal mass. In rats, it's been shown that you could have in utero effect to stimulate mammary development of the offspring. So this is a demonstration that in pigs, it can also occur. So it's another area where we can work, trying in utero to stimulate development so that when they reach puberty, they will have more mammary tissue. Let's talk about body condition. Does body condition of a gilt affect its mammary development? I will give you the scoop already. The answer is yes. If you look at back fat of 36 millimeters compared to 25, I thought that was cute. These authors said that 36 millimeters is fat and 25 millimeters is normal. I'm like, no, 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 no. This is an obese animal. So 36 millimeters is obese. Nobody has that on their farm. And 25 is fat. But when you compare these two, you have a lower mammary development in these obese animals. Less of this DNA, less alveolar cells. And milk yield in the next lactation is lower, 7 liters per day compared to 9 liters per day. So being obese has a negative impact on mammary development and future milk yield. Fine, nobody has obese animals. How about if we compare body conditions that we see normally in a commercial situation? So I've done 2 projects comparing low, medium, and high back fat, either at mating or at the end of gestation. In this study, we started with a similar back fat at mating, around 16.4 millimeters. Then I fed the same feed to all 3 treatments, but different amounts of the feed. And at the end of gestation, I had 3 groups. The fat group, which averaged 22 millimeters of back fat, medium group, 18, and the lean group, 14 millimeters of back fat. Interestingly, it is not the fat animals that were negatively affected in terms of mammary development. It's the lean animals. For once, being lean is not good. This is great. So anyway, being obese is bad. Being fat is good. But being lean is really bad also. So there's a point below 16 millimeters of back fat where you do see significant decrease in terms of parenchymal tissue and some change in composition, but not much. Mainly a significant decrease in parenchymal tissue. You have to remember this. Significant decrease in parenchyma when you have a lean animal at the end of gestation. Now, we move to this study. We have the same 3 treatments at the end of gestation. 23, 18, 13 millimeters of back fat. But for a different reason. Look at the beginning. They don't start at the same place. I'm starting at mating with animals that already differ in back fat. Something that is more inherent to them. And these animals, I'm maintaining these differences in back fat throughout gestation by feeding different amount of that feed. And what do I see? Not the same thing as in the previous study. Science it keeps you on your toes. You do a study, you say, oh, this is what I'm going to find. Then you look at this, oops, no, that's not it at all. This is really nice. So when you look at this study, the lean animals did not have less parenchymal tissue. But what happened is changes in the composition of this tissue. If you ask me what's most important, amount of composition, my gut feeling is amount. So it leads us to think that the back fat at mating is not what's so important, and also you can correct for it throughout gestation, because in itself it will not affect the amount of parenchymal tissue at the end of gestation. So feed intake in gestation seems more important than back fat at mating for the amount of mammary parenchyma. We know there's a negative impact if a gilt has less than 16 millimeters of back fat in a gestation, but being fat, 22 to 26 millimeters, has no negative impact on mammary development. Last thing I'm talking about, management in first lactation. Does teat use in parity 2 affect the milk produced by that teat in the second lactation? So what I've done is I've done a study where I've blocked either the same teats or different teats in parities 1 and 2. So you see an example here. This is in first parity. I kept 6 teats open, and I had left and right side, so I took into account the side of the animal. And I blocked everything else. So if I had 14 teats, we blocked the ones in the back, and then we blocked the others. So we have 6 good teats, and what we do, we keep 6 good piglets of similar body weight. So piglet weight is not an issue here. Then we move on to the second lactation. What do? We either block the same teats. So the piglets here are suckling a teat that was suckled before. Or we block the other teats. These guys have no choice. They have to suckle a teat that was not suckled before. Again, 6 piglets, so piglet weight is not an issue. If you look at the weight of piglets in second parity, at day 2, similar body weight. As time goes on, the difference in weight gets greater and greater. You get to day 56, significantly greater weight of the piglets suckling a teat that was used before, 1.12 kilogram more. This is important. Why? Because when you have a primiparous animal that's really thin, the producer says, oh, I'm going to get rid of some of these baby pigs to give her a chance so that I can keep her in my herd longer because she's going to have this thin sow syndrome. So then they ask, can I do that? Can I just remove piglets? Will it be okay for the next parities? Well, now I can tell them, no, these teats need to be suckled if you want to maintain lactation optimally in the next parity. However, I'll give you the however after. I forgot to give you this. If you look in second parity at the weight of these piglets, it's really interesting to look at the fact from days 2 to 4, you already see a difference. I did not measure colostrum yield, but when I look at this, I do think that colostrum yield is also affected, which would make sense because you have more cells that synthesize milk. So there may be also a difference in terms of colostrum yield. Why did we see all these? Well, you look at mammary tissue and it's evident. Look at significant increase in terms of the parenchymal tissue. And if you look at the amount of DNA and the amount of RNA per teat, significant increase. So it's just amazing. Because a teat is used in first lactation, it will grow more in second lactation and produce more milk. Then I go to the question I was talking to you about. Fine, I tell the producer, yeah, these teats need to be used. But for how long? Do they need to be suckled throughout the whole lactation? Or is just a short period okay to make sure that the mammary development will be fine in the next lactation? So I've done a study where the primiparous sows were divided in 3 groups according to the lactation length. So in first parity, they had either 2 days, 7 days, or 21 days of lactation. In the second parity, everybody had 21 days. In all cases, we had 12 piglets for 12 teats. Surplus teats were removed, runts were removed, 12 good piglets, 12 good teats. And we weighed the piglets in the second lactation to know, does it have an effect, the number of days that the teats were suckled in first parity? And the answer is no. No difference at any time. This could be boring to somebody, well, no significant, not interesting, it's the other way around. No significant means I can tell a producer 2 days is good enough. Yes, in first parity, all the teats have to be suckled. But if they're suckled for 2 days, you're fine. On day 3, remove your piglets, and that mammary gland will have adequate mammary development in the next lactation. So this is really interesting from a practical aspect. So what do I conclude? Gilts should be fed to maximize their mammary development before lactation starts. In the prepubertal period, from 90 days of age to puberty, we don't want to have a feed intake below 2.7 kilogram per day. I don't know how far back we could go. I know 2.1 is too low, but 2.7 is okay. So I'm going to leave it at 2.7. And that was, with the Yorkshire Landrace breed. So maybe with other breeds it could be different. But amount of feed, there's a limit below which you cannot go. If you can have a source of phytoestrogens that will stimulate mammary development, if you can increase prolactin somehow, you can increase mammary development. In gestation, from day 90 of gestation to farrowing, you don't want to feed too much energy. You want to increase prolactin, however we can, and you don't want to feed ergots that will have a negative impact on prolactin. You want to increase IGF-1, so eventually, if we have nutritional means to achieve that, that would be great. You want to increase the amount of lysine. Right now, I can tell you, increasing lysine by adding soybean. That's what I can tell you. If you increase lysine by increasing soybean, you will increase mammary development. And I'm going to give you a scoop here. Right now, there's an American company doing this with 100 sow per treatment on a commercial basis, just to look at, does that treatment affect growth rate of the piglets? So in a few months, I will have an answer from a commercial setting with a large number of animals on that treatment. So I'm looking forward to this. If you feed 10% of flaxseed in gestation and lactation, it will increase mammary development of the female offspring when it reaches puberty. Now, what can you do throughout gestation? Well, what's most important is to control body condition of the animals. So you have to feed the animal to achieve a body condition at the end of gestation, which is greater than 16 millimeters up to 26 millimeters. There's quite a good range there, but you don't want extremes. Not overly fat and not overly thin. And right now our problem is more on the overly thin section, because you do see some gilts that are below 16 millimeters sometimes at the end of gestation. And obviously, management in first lactation, as I mentioned, teat use is important. You have to make sure that all the teats are suckled for the first 2 days of lactation. After that, you can do whatever they want. And thank you, everybody, for listening to me. And if you have any questions, you can ask them now or write to me, and I'll always be happy to answer any questions you may have.
Thank you very much, Chantal. I already see a hand up over there for questions.
Very nice. I enjoy always your presentations.
Thank you.
Yeah, of course, as a users industry, we have a challenge with the mammary gland, the total born, the born alive, and, if we need to do a lot of nurse sows because we don't have enough amount. So you suggest very interesting points to administrate or increase what we have. But it's still not enough, right? So I like you show hormones, nutrition, and body condition and management. In terms of management, there is something else that we can do. I don't know if you have data that suggests difference between how do you raise gilts, like age of breeding or weight of breeding, if has an impact in mammary gland develop. I know it's related with body condition, but something else, or saying estrus versus not estrus, hypnos service. There is more data that we can do in the gilt develop to increase mammary composition or amount?
The answer is no, but I will give you my gut feeling. What I presented to you today is what we know. Nobody else looked at anything else on mammary development except compensatory feeding. I did not show that because it was not conclusive, which I could have added. But I want to go back to your age at breeding. In that second study, where I looked at back fat thickness and at mating, I already had differences. What I didn't tell you is that the animals that were fatter were also older. So being older at mating did not affect the amount of parenchymal tissue at the end of gestation. And what you feed during gestation is most important. So I don't think that age at puberty will have an impact. Can some other management procedure, anything related to estrus, be related? I have no idea. But that's what we know for now. More work needed. I want young scientists to be involved in that field.
Great work. I appreciate your information today. I was just wondering, you've done a lot of look at milk yield and piglet weight. Have you looked at subsequent total born performance in those same sows by milk yield? As we push sows harder and see higher lactation lengths or higher lactation numbers, we're also seeing better subsequent total born. So just curious if you've looked at that.
In the next parity after?
In the next parity.
Well, first of all, I always standardize my litter size when I look at milk yield. So I'm already biasing your data here. And I don't go back and look what happens because we have animals to do a research project, and if they're not used by somebody in the next, goodbye. So this is something for genetic companies to look at. I didn't point anybody, did I? But so I couldn't answer your question either way. Yep.
Are there any other questions from the audience? Yep.
Hello, Dr. Farber. First of all, thanks for your presentation. We really enjoy it. I have a question. So in regards to the potential impact on feed restriction during the development period of time of a gilt, do we need to be concerned for farms, for example, with ESF system during the period of time that we are training a gilt, that is pretty much 2 weeks? Usually we have there a restriction on feed intake since the gilt is learning how to basically get feed from the ESF. Pretty much during the first week is even more critical. Can be that basically something that we need to...
How old are they when you do that?
25, 26 weeks of age.
So that would be 6, so they're right in the period where you do
They're
see
right there
mammary
in that
development.
period of time.
I don't know if a short period of 2 weeks is enough to have a negative impact. And do they catch up after that? I mean, do you give them a chance to catch up, or they're restricted as much? Or no, they're ad lib.
Within that population, you have animals that catch up,
No, you're right.
others that no, so that's...
Oof, that's interesting. That's interesting. I don't know if 2 weeks, my gut feeling is I hope that they would eat enough afterward to make up for that 2 week period.
Yeah, no, not knowing this information before, we try to put our animals in a kind of recovery period of time after training,
Okay.
putting them full feed, but at the end of the day, it's interesting to think if they are able to catch up
Yeah.
for the restriction that they have pretty much during 2 weeks,
That's
learning how to eat.
That's an interesting question.
Okay.
I would hope that it doesn't affect that the animal can make up for it, but no one's looked at it.
Okay.
Yeah, it's
Thank you.
pertinent, yeah.
Another potential research study there.
Boy,
Are there more questions from the audience? Okay.
I guess just also curious to know what happens during the development of gilts, that there are programs of people that use infections or expose gilts to diseases like mycoplasma or pneumonia. Would that infection or a disease in that period of development affect mammary development?
from those back fat studies, when I go back and I look at the growth rate, obviously growth rate is different. And also from the feed restriction studies, obviously growth rate is different. So if a disease can really slow down growth rate for a long period of time, it comes back to the same question we had, would that have an effect? How long does it take to have a negative effect? So anything between 90 days and puberty will have a negative impact, but how long does it take and how much of it? You know, if you slow down growth rate by 5%, is it bad enough? Does it need 10%, 15%? And for how long? So I don't have the answer to that question. You want to maximize growth. Oops. Something's gone. Oh, there we go. If it's a short period, you'd presume it would be okay. But if the animal is really sick for weeks and weeks and weeks and has a lower feed intake all this time, then...
You said day 90 to puberty.
Yeah. Before day 90, doesn't matter. Doesn't matter at all.
Okay, with that, I think in interest of time, we should thank Dr. Farmer again.